Hello everyone. The title of this video is Graph a Circle. Every exercise I'm going to be doing in this video is taken directly from a free online textbook at openstax.org. It's their Intermediate Algebra 2nd edition text. I'm in section 11.1 called Distance and Midpoint Formulas and Circles, and I'll be under the heading Graph a Circle. Now, I'll only be working on the even numbered exercises, so the ones that don't have a link to the solutions. Right? The odd numbered ones do, so I won't be doing those. So I'll be doing exercises 30, 32, 34, all the way to 48. Right? All the even ones to 48. Alright, and I'll also have timestamps in the description of the video for each of these examples. So example 1's timestamp will be for the beginning of exercise 30. Example 2 will be for exercise 32, and so on. Alright, I also ask of you that when I start a new question in the video, pause it and try to do it yourself first before watching me do it and then comparing. Because if you're just watching me do these questions and not practicing yourself, chances are you're not learning all that much. Alright, so in each of these exercises in the video, we're going to be asked to A, find the center and radius of the circle, and then of course graph the circle. Alright, and I'll draw a hand drawing of the graph, and I'll also go to that Desmos.com, a free online graphing calculator, to graph it as well. Alright. Okay, so number 30 is the one I'm starting with. I have that written out. Alright, example 1, exercise number 30 from the text. Now, first we're asked to find the center and radius. Now, I've done a video on this prior to this one. Hopefully you recall what the standard form for the equation of a circle looks like. I'll write it again here. The standard form for equation of a circle. And that was the following. You have the quantity x minus the x coordinate of the center of the circle, which was labeled h squared, plus the quantity y minus the y coordinate of the center, which is labeled k, that quantity squared, equals the radius squared. Alright, so where h comma k, right, is the center of the circle, and r is the radius of the circle, right? The distance from the center to any point on the circle. Right, and I'll put this in a little box. Right, this is very important. You should know this. Alright, so for a little bit, a few of these exercises in the beginning, the equation that we're given for a circle is already given in standard form. So hopefully you can see this. We have number 1, the quantity x minus 2 squared. So we have x minus, and then 2 is the h, right? 2 is the x coordinate of the center. Plus, and then y minus, y minus the y coordinate of the center, which is, k, that's 3 here. K is 3. So the x coordinate of the center is 2, the y coordinate of the center is 3. And then this number on the other side is the radius squared, right? So r squared equals 9, meaning that the radius is the square root of 9, right, which is 3. Right? I know negative 3 squared is also 9, but we're not going to talk about having a negative radius. So that's part 1, right? The center of this circle would be the point 2, 3, right? 2 for the x coordinate, 3 for the y coordinate, and the radius is 3 units, right? The square root of this 9. So that's part 1 of what they're asking us to do. Put that in a circle, a box here. Now part 2 is graphing. Right, like I said, I'm going to graph it by hand and also show you a picture in the Desmos graphing calculator. Alright, so just going to make as best I can, right? It's a hand drawing, it's not going to be perfect. There's x-axis, y-axis. So first I'll label the center, right? 2, 3. So 2 on the x, 3 on the y. Now this actually isn't a point on the circle, right? The center does not satisfy this equation. Right? If you plugged in 2 for x and 3 for y, you'd get 0 plus 0 equals 9. Right? That's false. So this is just a point I'm going to put that's a guide, right? There's the center of the circle. It's not actually on the circle. I hope you understand that. But it's a guide to help us, find the actual points on the circle. So the actual points are all 3 units away from this point. So the easiest points to find are the points directly above and below the center and directly to the right and left of the center. So I'm going to go 3 units above the center, 3 units below the center, 3 units to the right of the center, and 3 units to the left of the center. All right, let me plot these points. So 3 units above the center would be this point here. All right, that's the point 2, 6. And check it out. Plug in 2 for x and 6 for y. You'd get 0 plus 3 squared is 9. 9 equals 9. That's true. So the ordered pair 2, 6 does belong to this circle, does belong to the graph of this equation. So that's 3 units above the center. 3 units below the center would be this point here, which has the coordinates 2, 0. And again, check it out. Replace x with 2 and y with 0. You'd get 0 plus negative 3 squared would be positive 9. That's also true. Then 3 units to the right of the center would land here, which has coordinates 5, 3. And 3 units to the left of the center would land here. Sorry, it's on the number 3 there. There's negative 1, 3. Right, and again, check these out. Plug in 5 for x and 3 for y. You'd get 3 squared plus 0 equals 9. That's true. Plug in negative 1 for x and 3 for y. You'd get negative 3 squared, which is 9, plus 0 is 9. That's also true. All right, and then I'm going to draw a rough sketch of the rest of the circle, right? Because these aren't the only 4 points that are 3 units away from the center. Right? So I'm going to draw my best circle, just a rough sketch. Right? So bear with me here. I'm just going to try to make this look as circular as possible. And I like to kind of go 1 quadrant at a time here, 1/4 of the circle at a time. it might not look like a perfect circle. I mean, I'm doing it by hand here. Okay, there we go. Back straight, right side up here. And here we go. Right, all these green points I just put in should be points that are 3 units away from the center, 3 units away from the point 2, 3. There we go. Alright, and then just to confirm that my drawing is decent, I'm going to go to a graphing calculator. Remember, this was this Desmos.com, a free online graphing calculator. And we can just enter the equation that we were given as it looks. X minus 2 squared plus y minus 3 squared equals 9. And look at this circle that just popped up. And now they got the y-intercepts here, and let me put the center up as well. Right? We said the center should be at 2, 3, and you can see that green point that just popped up is clearly in the center of this blue circle. And there's 2, 3. And we said this was 2, 0, right? The 3 units below, and we had that on our graph. This should be 2, 6, right? 3 units above. Then this should be 5, 3, right? 3 units to the right. And this should be negative 1, 3, right? 3 units to the left. I had those 4 points up, and then I drew a picture of all these other points, right? All these other ordered pairs as you move around the circle should also be 3 units away from the point 2, 3. All right, so my circle didn't look too much different than this. Obviously, this is better looking because it's a computer generated, but looks pretty decent what I have drawn. Right. But yeah, so identify the center, the radius, figure out where the center is on the coordinate plane, and then use the radius and go from the center, go up and down and left and right, that many units, plot at least 4 points, and then draw the rest of the circle in, right, as best you can. Right, try to make it look reasonably circular. All that I ask is that you don't make a diamond, right? Don't make it sharp. Right? It should be circular looking. Okay. Great. Next question. Right, so again, I hope you should know this. I'm not going to keep this on the screen anymore, the standard form equation of a circle. Alright, so this equation here, number 2, exercise 32, this is in standard form. But remember, you got to think of it as x minus h squared plus y minus k, right? The x coordinate of the center is the number being subtracted from x. The y coordinate of the center is the number being subtracted from y. So I'm going to rewrite x plus 2 as x minus negative 2. Right, and then we got the square. And then the second quantity is already a subtraction, already a difference, right? Y minus 5 squared equals, and then 4 is just, 2 squared. So we're seeing from this that h is negative 2, k, right, the number being subtracted from y in that quantity square, is 5, and then the radius is 2, right? This 4 is the radius squared. So the radius is the square root of 4, right? It's positive 2. So the center is the point negative 2, 5. The radius is 2. All right, so that's part 1. And then part 2 is drawing a rough sketch. So I'm going to do the best I can by hand here. Alright, so the center is at negative 2, 5. So negative 2 on the x, positive 5 on the y, And so here's the center, -2, 5, right there. I'll put C for center. That's not actually on the circle. Alright, so now let's get all these points that are actually on the circle. All the points that are 2 units away from the center. So 2 units above, I'll make it a little bigger, that's the point -2, 7. Right, that should be on the circle. That should satisfy the equation. Replace x with -2 and y with 7, and that original equation should be true. 2 units below would be at -2, 3. And again, check it out. Replace x with -2 and y with 3, and the equation will be true. 2 units to the right is a y-intercept here. This is 0, 5. And 2 units to the left of the center is -4, 5. And once those up, down, left, right points are in, you can make a rough sketch of the circle. I'll do it without turning the paper this time. There you go. And that's pretty circular looking. Not a perfect circle, but it's okay. Alright, and then once again I'll go to the Desmos site and just verify that all these points are on there. Right, type in the equation that we were given. X plus 2 squared plus y minus 5 squared equals 4. And yeah, look at this, right? There's -2, 7, 0, 5, -4, 5, and -2, 3, right? And the center would clearly be at -2, 5 if you want to put it in. But those 4 points, the up and down and left and right points, are all there, and then all these other points should also be 2 units away from the center. Alright, looks good to me. Alright, next question. Alright, yet another equation that's already in standard form, right? I've got a square plus a square equals a number. A square with x plus a square with y equal to a number. So this is already in standard form. I just have to identify the h, the k, and the r to be able to identify the center and the radius. So this is x minus 1 squared, and then y you can think of as y minus 0, can't you? Squared, right? If we want to think of these as differences squared, equals, and then 36 is simply 6 squared. So I'm hoping it's obvious that the center has an x coordinate of 1 and a y coordinate of 0. And the radius of this circle is the square root of 36, right, which would be 6. Okay. So I've identified the center and radius, and now I should be able to draw a rough sketch of this circle. And again, if you have graph paper, that might be a little better for you. Alright, so here's 1, 0, so there's the center, and then we're going to put a point 6 units above, 6 units below, 6 units to the right, and 6 units to the left. Alright, yeah, so the center is 1, 0. Right? I'm going to put C there for center. It's not actually on the circle. Alright, then 6 units above this, make that a little bigger, there's the point 1 comma 6, right, and that should satisfy the equation. So should this point 6 units below the center, right, 1 comma negative 6, and check it out, make sure it satisfies the equation. 6 units to the right, there's 7, 0. 6 units to the left, here's negative 5, 0. And again, check out those 4 points, make sure that they actually satisfy the equation, and then I'm drawing the rest of them in, just roughly. I'm trying to make it look as circular as I possibly can. Sorry about that errant mark there. Then we got Alright, so something like that. I mean, it's not a perfect circle by any means, but as long as you're trying your best to make it circular shape. Alright, once again, just for a better looking picture, and to see that all 4 of these points are actually on it, I'm going to put it on Desmos. So we're given the equation x minus 1 squared plus y squared equals 36. Alright, look at this. Alright. So there's 1, 6, there's 1, negative 6, here's 7, 0, and negative 5, 0. Excellent. All the points that I said would be above and below and right and left of the center. And all these other points, right, should be 6 units away from the center as well. Looks like a good circle to me. Okay, next question. Alright, so we're still given an equation in standard form. See, I've got a quantity with x squared plus a square with y equals a number. Right? You see stuff like that, that's in standard form for a circular equation. And it's already written out the way I want. Difference squared plus difference squared equals, and remember this is the radius squared, 9/4. So the radius would be the square root of that, right? The positive square root of that, which would be 3/2, 1.5 units. Alright, so the center is, the x coordinate would be 1, y coordinate, y minus, 3, 1, 3. And the radius, as I've already stated, is the square root of this number, 3/2, right? 1.5, 1.5, however you want to say it. Alright, so I've identified the center and the radius. Now I will plot some points. Alright, so center's at 1, 3, so there's 1 on the x, and 3 on the y. Alright, so there's the center, C. And then we're going 1.5 units away from the center, right? So there's 4 and 5. So here's a 4.5. I'll just put 4.5. Then 1.5 units below will be at a y value of 1.5. 1.5 units to the right would be at 2.5, or 5/2 if you want to write fractions. And then 1.5 units to the left will be at negative 0.5. Sorry about the clutter again. Yeah, so I'm going to plot points. So the center's at 1, 3. I go 3/2 units away, 1.5 units up. Alright, there's the point 1, 4.5. 1.5 units below. Here's the point 1, 1.5. Or 3/2, this is 9/2, 3/2 if you want to write fractions. Then go 1.5 units to the right. So here's 2.5, 3, and 1.5 units to the left. it's going to be on the 3 there, sorry, there's negative 0.5, comma 3. And I can make a rough sketch of a circle with these 4 points. Again, trying my best to make it circular looking. And there you go. And again, just to double check my work, I'm going to enter the equation we were given, see that these 4 points show up, and look circular. Alright, so the equation we were given here is x minus 1 squared plus y minus 3 squared equals 2.25, right? 9/4, 2.25, you can put 9/4. And yeah, look at the points, right? 1 comma 4.5, I had that. 1 comma 1.5, I had that. 2.5 comma 3, I had that. Negative 1/2 comma 3, I had that, right? So and then all these are centered at the point 1, 3. And every point on this circle, right, should be 1.5 units, 3/2 units away from the center. Looks good. All right. Next question. All right, this is going to be the last one that's in standard form in the beginning. After this, we're going to have to put the equation in standard form ourselves. So you see I have a quantity with x squared plus a quantity with y squared equals some number. Now if you want to think of these as differences, right, this is x minus 0 squared plus, and then y squared is the same as y minus 0 squared equals, and then 49 is 7 squared. Right? So clearly the center has an x coordinate of 0 and a y coordinate of 0, right? The center is the origin. The center is 0, 0. And then the radius, right, is the square root of 49, which is 7. Right, so center, 0, 0. Radius, 7. Pretty easy to draw this one. So just go, center is at the origin. Just put a C there. And it's 7 units above. Seven units to the right. 7 units below. And 7 units to the left. Again, this is a hand drawing. So probably not perfect spacing here. So let me just plot these points right there. 0, 7, 7, 0, 0, negative 7, negative 7, 0, and then the rest of these on a circle, right, centered at the origin. Something like that. Now, again, it's not a perfect circle, it's a hand drawing. But let's take a look on Desmos and see that those points actually show up. So this is x squared plus y squared equals 49. Zoom out of it. And yeah, you're seeing 0, 7, 7, 0, 0, negative 7, negative 7, 0, right? All around the center of 0, 0. And every single point here should be 7 units away from the origin. Great. Alright, so now we are given an equation that's not in standard form yet. And once again, I'll write out the standard form here. All right, remember it was some quantity with x squared, x minus h squared, plus some quantity with y squared, right, y minus k squared, equals some number squared, right, the radius squared. Notice that, yeah, there's an x squared, plus there's a y squared, but there's a coefficient of 6 on these. In the standard form, the coefficient on these squares is 1. Right? Each of these squares has a coefficient of 1. So very simply, I just divide everything by 6 right now. And that will get rid of those 6's. So now I'll have x squared plus 1y squared equals 36. 216 divided by 6. Now we are in standard form. And once we're in standard form, then it becomes like questions 1 through 5. Right. See, I've got an x squared with a coefficient of 1, some quantity y squared with a coefficient of 1 equals a number. That's standard form. Alright, so here I'm hoping you can see that the center would be the origin again, right? X minus 0 squared, y minus 0 squared, right? So the center's the origin. And the radius is the square root of this number, right? This is r squared. So the radius is 6, right? The square root, the positive square root of 36. All right, and again, a pretty easy one to draw. So center's at the origin. I'll just put C there at the origin. 6 units to the right. There's a point there. 6 units below. There would be a point there at 0, negative 6. 6 units to the left. Negative 6 comma 0, and 6 units above. There'll be a point there. Right. So I have 0, 6, 6, 0, 0, negative 6, negative 6, 0, and all the other points on the circle. All the other points that are 6 units away from the origin. And again, not a perfect circle by any means, but reasonably circular. And once again, let's test it out. Now I'm going to enter the equation. Oops. Hello. I'm going to enter the equation as it was given to me in the beginning, right? 6x squared plus 6y squared equals 216. And look at this. See this circle? Got 0, 6, as I said, 6, 0, 0, negative 6, negative 6, 0, all circle with a radius of 6 centered at the origin. Okay. Yeah, and we're going to have to be doing that for the rest of the problems, right? We're going to be given an equation that's not in standard form. We have to put it in standard form. Identify the center and radius, then graph. All right, now this one was pretty easy. We just divided by 6. Next one's a little trickier. So number 7. Got x squared plus y squared. Great, that's what I want. But notice there's these x to the first and y to the first terms. Those have never appeared yet in questions 1 through 6. So here, in order to turn this into standard form, I want an expression with x alone in a square, and an expression with y in a square, and no x is outside the square, no y is outside the square. Well, that's going to involve completing the square. You're going to, for something like this, we're going to complete the square in x and y. Right? We're going to complete the square twice. So watch what I mean. So first I'll gather the x terms together. We have x squared minus 6x. And we have a quadratic term with a coefficient of 1 and a linear term. So I can complete the square on this expression here. We'll do that in a second. So I'm going to leave a little space, because we're going to add some number to complete the square. And then I'll put the y terms. You got positive 1y squared, then minus 8y. And again, we have a quadratic term in y with a coefficient of 1 and a linear term in y. So we can complete the square on the y's as well. So I'm going to leave a little space for that. And then we have equals 0. Alright, now I'm hoping you remember how to complete the square. I'm not going to teach all that again. Alright, just going to get into it. You needed a quadratic term and a linear term, with the quadratic term having a coefficient of 1. Then you took the linear term, you cut it in half, right? Half of negative 6 is negative 3, and then squared that, which would be positive 9. So when I complete the square on the x's, I'm adding 9. Now don't forget it's an equation. So if I add 9 to the left side, I have to also add 9 to the right side. Okay, hopefully that's clear. And then I'm going to do the same thing for the y's. There's a quadratic term with a coefficient of 1 and a linear term. So I can complete the square on the y terms. Take the half the linear coefficient, right? Half of negative 8 is negative 4. Then square that. That's positive 16. So I'm going to add 16 to complete the square on the y terms. And don't forget it's an equation, right? If I add 16 to this side, I must also add 16 to the other side. Right, now the whole reason for adding this 9 and 16 is to get perfect square trinomials. Right? We have completed the square on x. X squared minus 6x plus 9 can be expressed as x minus 3 squared. Right, it's the variable x plus whatever half that linear coefficient was, that quantity squared, right, after you complete the square. Plus, right, and then the y terms, the same thing. When I added this 16, I created another perfect square trinomial in y. Y squared minus 8y plus 16 can be re-expressed as y minus 4. That quantity squared. And I leave it to you to check that. Take y minus 4 times y minus 4. FOIL and just combine like terms, you'll get y squared minus 8y plus 16. Same thing with x minus 3 squared. You get x squared minus 6x plus 9. Equals, and then 0 plus 9 plus 16 is 25. And now, the equation is in standard form. Wonderful. Right. See, I've got a quantity with x squared plus a quantity with y squared equals a number. That's standard form for the equation of a circle. Alright, now that it's in standard form, you should be able to easily identify the center of this circle. X minus 3, right? So 3 is the x coordinate of the center. Y minus 4 squared, so 4 is the y coordinate of the center. So the center is the point 3, 4. Remember, this side, this number, is the radius squared. So the radius squared is 25. That means the radius is the square root of that, right? The positive 5. So it has a center at 3, 4 and a radius of 5. Right, now I'll draw it. And as best I can with my hands. Alright, so 3, 4, 3 on the x, 4 on the y. Alright, so here's the center. Let's put a C next to that. And then the points that are actually on the circle are all 5 units away, right? The radius 5 units away from this. So 5 units above. Sorry about the tightness there. That's 5 units below. 5 units to the right. And 5 units to the left. Right, so 5 units above the center would be the point 3, 9. Right, 3, 9. 5 units to the right of the center would be 8, 4. 5 units below the center would be 3, -1. And 5 units to the left of the center would be -2, 4. And then, now that I got these 4 points in, I can make a rough sketch of the rest of the circle. All the other points that are 5 units away from the point 3, 4. Oops, hit a groove in my table. Alright, something like that. That's not very good looking, but try my best to make it as circular looking as possible. Alright, now let's see. Let's verify this with Desmos. So again, I'm going to enter the equation the way it was given to me and show you. Alright. So we had x squared plus y squared minus 6x minus 8y equals 0. And look at this circle that just popped up. Alright, I'm going to put in the center we found, right? The center was 3, 4, and definitely in the middle, right? Definitely in the middle. And look at all these points, right? There's 3, 9. We had that on our graph. There's 3, -1. I had that. Here's 8, 4. Here's -2, 4. I had all those points, and then all these other points, right, should be 5 units away from the point 3, 4. So looks like we did a good piece of work. All right, and this when there's an x to the first term and a y to the first term with these squares, we're going to be doing this, completing the square in x and y each time. All right, so the same thing's happening in the next problem. All right, so number 8, exercise 44. See, I've got an x squared term, but I also have this x to the first term, so I need to complete the square. So I'm going to rearrange these. We have x squared plus 12x, right, and then I'll leave some space because I can complete the square on these. Then we have a positive 1y squared term, and then minus 14y to the first. And then I'm going to leave some space to complete the square in the y's. The only thing I don't need is the 21. All right. In order to complete the square, you only need quadratic terms and linear terms. So I don't need 21. So I'm going to subtract 21. I'll get 0 minus 21, or -21 on the other side. Okay. So now again, I'll write it. We complete the square twice. Right? You do it for the x's and the y's. I'll say complete the squares, plural. Alright, so on the x's, I'm adding 36. Right. And then I would do the same to the other side. Right. Don't forget it's an equation. And then on the y's, I would be adding 49. Alright. Now the adding of this 36 and 49 give me perfect square trinomials over here, right? X squared plus 12x plus 36 is the quantity x plus 6 squared. Alright, then I got plus, and then y squared minus 14y plus 49, that's the quantity y minus 7 squared. Alright. Equals, and then here, 36 minus 21 is 15, and then 15 plus 49 is 64. And now the equation is in standard form. I'm just going to write standard. I have a quantity with x squared plus a quantity with y squared equals some number. Perfect. So I should be able to identify the center and radius real fast. Now remember, x plus 6 is the same thing as x minus negative 6, right? Negative 6 is the x coordinate of the center. Y minus 7, so 7 is the y coordinate of the center. So the center is at the point negative 6, 7. And the radius, right, this is the square root of 64, the positive square root would be 8. Remember that number on the other side is the radius squared. Alright, and then I'll draw this again as best I can by hand first, and then we'll take a look at it in Desmos. Alright, so negative 6 on the x, 7 on the y. Alright, so here's the center. Put a C there. And then we're going 8 units away from the center for all the points on the circle. Alright, so 8 units above. So that'd be at 15 there, and then 8 units below would be at negative 1 on the y. 8 units to the right would be at positive 2 on the x, and 8 units to the left would be at negative 14. Alright, so plotting all these points, there's a center, go 8 units above. 15 here, there we go. This is the point negative 6, comma 15. 8 units below. Here's negative 6, negative 1. 8 units to the right, there's 2, 7. And then 8 units to the left, negative 14, 7. And again, you can put in the ordered pairs, put in all these x and y values into the equation that we were given and see if it makes a true statement. It should. And then I draw in a rough sketch of the circle. And again, this isn't going to be great, but something like that. That's reasonably circular. Alright, and then I'm going to double check myself. Alright, I'm going to put in the equation we were given as is and see if these, the graph of a circle comes up and if these 4 points are on it and if the center is the point negative 6, 7 and all that. So the equation we were given was x squared plus y squared plus 12x minus 14y plus 21 equals 0. Look at this circle that popped up. Alright, so I'll put in the center, right, negative 6, 7. Right, negative 6, 7, and look at that, definitely in the center of this red circle. And then all the special points, this is 8 units above, right, the radius is 8, negative 6, 15 was on our graph. Here's negative 6, negative 1, here's 2, 7, and negative 14, 7. I had all those points, right, and every other point on the circle, right, should be 8 units away from the center. Fantastic. Okay. Got just 2 more of these, where we're completing the square to put the equation in standard form. Alright, but this time, see how there's an x squared, but there's no x to the first term? So I don't need to complete the square on x, it's already a square, and the coefficient's 1. So I'm good with the x's. It's the y's, right? I have a y squared term, but I also have a y to the first term. So I need to complete the square just on the y's, right? There's no need to do it for the x's. So we have x squared plus, and then y squared minus 10y, and then I'll leave a little space for the number we're going to add to complete the square on the y's. Alright, and that number would be 25. And I do it to the other side as well. Add 25. Alright, so we still have a square with x, right? X squared plus, and then here comes the square with y. Y squared minus 10y plus 25 is the quantity y minus 5 squared. and then 0 plus 25 on the other side is 25, and now we have an equation for a circle in standard form. Something with x squared plus some quantity with y squared equals a number. The center should be easy to identify, right? The center, the x coordinate of the center would be 0, right? This is x minus 0 squared. And this is the y coordinate of the center would be 5, right? It's y minus 5 squared. So the center is at the point 0, 5, and the radius is the square root of 25, which is 5, right? A radius of 5 units. All right, so I've done the first thing, identified the center and radius. Now I'm going to graph it. Right. So 0, 5. Right, so there's the center. It's on the y-axis. Right. And then we're going a radius of 5. So 5 units above to 0, 10. 5 units below to the origin. 5 units to the right. And 5 units to the left. Alright, so the points on the graph, there's 0, 10, 0, 0, 5, 5, negative 5, 5, right, and then the rest of them that are on this circle, all these points that are 5 units away from the center. And let's see, I'm going to enter the equation again as I was given it initially on the Desmos site and see that we get that same circle. So x squared plus y squared minus 10y equals 0. All right. And you're seeing, there's 0, 10, 0, 0, 5, 5, negative 5, 5, right? The center would be at 0, 5. I'm not going to put it in this time. We've got the correct points. We've got the correct circle drawn. Excellent. Alright, and I just got one more like this, where we have to do some completing of the square. Alright, so again, say I have x squared and x to the first term, so I need to complete the square on the x's, right, to start putting this in standard form. Complete the square in x. But notice there's a y squared, but no y to the first term. So I'm not going to need to complete the square in y. So I'll gather the x terms together. We have x squared minus 14x. And then I'm going to be able to complete the square on these, so I'll leave a little space. And then we got plus y squared. And that is the square that I need for the y, right? Equals, and then negative 13, right? I don't need this plus 13. Right, so take it away. Alright, so now completion of the square on the x's, I'd be adding 49 to complete the square. And if you add 49 there, you must add 49 over here as well, right? Don't forget it's an equation. And then that completes the square on the x's, so the square with x is the quantity x minus 7 squared. And the square with y is already there, it's just y squared. Equals, and then 49 minus 13 is 36. Now we have the equation in standard form. Fantastic. And once it's in standard form, should be able to identify the center and the radius quickly, right? The center, now it's x minus 7, right? So 7 is the x coordinate of the center. The y coordinate, y squared is the same as y minus 0. Right? So 0 is the y coordinate of the center. So center's at 7, 0. And the radius would be 6, right? The square root of 36. Remember, this is r squared. Alright, so I have the center and the radius identified. Now I'll make a rough sketch of the graph. Alright, so 7, 0. There's 7, 0. There's the center. Put a little c next to it. And the radius is 6, so I'm plotting points that are 6 units away from this. So 6 units above, 6 units below, 6 units to the right, that would be at 13, 6 units to the left would be at 1, And I'll plot these points. So 6 units above the center would be here. That's at 7, 6. 6 units to the right, that's 13, 0. 6 units below, that's 7, negative 6. And 6 units to the left is 1, 0. Right. And then I plot the rest of the circle, a rough sketch of it. All the points that are 6 units away from the point 7, 0. And again, just roughly drawing it in, making it as circular as I think I can. All right, let's test this out one more time. Let's make sure I get the same graph in the Desmos site, a little better looking graph, right? It'll actually look like a circle. All right, so the equation I was given was x squared plus y squared minus 14x plus 13 equals 0. All right, now the center was 7, 0, but look at these points. All right, 7, 6 I had on my graph. 13, 0 I had on the graph, 1, 0 I had on the graph, 7, negative 6, right, had on the graph. And then all these other points that are 6 units away from the point 7, 0 in the middle. All right, and if you want to plot the 7, 0, you can. Just make sure you know that it's not actually part of the circle, it's just a center, just a guide. Wonderful, so it looks like I did a good job again. All right, and that's it. All right, I know that's a lot. But here we were, given the equation of a circle, asked to find the center and radius. If the equation was in standard form to begin with, that was easy. If it wasn't in standard form, like these last 5 questions, you had to manipulate the equation somehow, either by completing squares in x or in y or in both, to put it in standard form, and then identify the center and radius and then graph it. Right? And graphing was simple, right? Locate the center, and then use the radius to find a point above, below, left, and right of the center, and then sketch in the rest of the circle as best you can, as best as you can eyeball it. Great. Alright, so I'm hoping that watching me go through these 10 questions here, these 10 examples, help you, in some way when you're asked to graph a circle given some equation for a circle on your own. And thank you very much for watching.